Hi, my name is Gwendolyn Espy, and I'm the owner of UpTop Solar, and I will be walking you through the Solar 101 series. In this video, we will be conducting a technical overview of what makes up a solar power system, or PV system. We'll go over at a high level all the components that make up a PV system and briefly talk about the different types of systems. First, however, we'll review some definitions, then the major components that make up a PV system. We will go over the system itself from a bird's eye view. And then lastly, we will ask the question, what are your solar goals? Now, this is really important because this will dictate what type of system you might get. Well, let's get started. Let's go over some definitions first. Power. Power is a rate per unit time at which electrical energy is transferred by an electric circuit. Electrical power is measured in watts. You often will hear the term kilowatts, which is 1,000 watts essentially. If you think about it like a car, the rate at which you're burning fuel is power. Chemical energy being converted to power in this case, depending on how fast you need the car to go, will vary how much power it's producing. Same with electrical loads. Some loads like a refrigerator or oven will have varying power demands. One moment, it might need 300 watts and another 1,000 watts. Energy is the ability to do work. To continue our car analogy, this is our fuel or fuel tank. Batteries are a form of storing energy, like a fuel tank. And similar to how an odometer can track approximately how much fuel or energy you have burned, using the car's known fuel economy and the total miles traveled, an electrical meter can also track how much energy we have consumed over time, or sold back to the grid, but more on this later. Energy is how much power you have used over time, similar to miles per hour over time. For example, if you're driving 60 miles per hour for 1 hour, it's 60 miles, right? You can calculate how much gas you burned by using the average miles per gallon. Similar idea. Energy is how much power used over time, or how much power available over time. Sun hours is a way to quantify how much usable energy your location is able to harvest. Factors that can change this are time of day. This is pretty self-explanatory. You can't harvest at night or if the sun is down. Season. The amount of sun varies based on the season. And geography. In the northern or southern parts of the world, you'll get more or less drastic seasons where you'll get more or less sun. This is also considered. There are 4 main parts of a PV system. 2 are optional, depending on the type of system. The first component are the PV modules. Second are optimizers, which are optional. The third is an inverter or solar charger, depending on the system. If you have a solar charger, also known as a charge controller, you should have batteries as well. PV modules convert solar rays to direct current, or DC, electricity. It cannot be turned off or on. Any sun exposure will cause the module's conductors to be energized. When a string has one module covered or damaged, it will affect the whole string and may not produce anything. And we'll go over strings, the meaning of strings later. Optimizers can be connected to each module so that in this case, where one module isn't performing, it doesn't take out the whole string. This is optional, but it will increase performance. Now, we're going to take a step back and view this PV system from a bird's eye view. There are 2 types of systems. A grid-tied system with an inverter and no battery. This is what we see here on the top. It's a simple DC to AC converter, which is an inverter. There's also a battery-based system with batteries. These systems have an extra component called solar chargers or a charge controller. If you can see my mouse, this is what this is here. So these systems have an extra component, this extra component here, to properly charge the batteries. After the batteries, you'll have an inverter to serve the household loads. In most cases, these are the two different systems that you'll come across. So you'll need some type of converter to convert DC power from the roof to usable power that the homes use. And that's true for both of these. So for this one, you have your PV power going into, for the top one, you have PV power going into the inverter, and then the inverter will convert it from DC to AC to serve your home loads. On the second example, we have a battery-based system. So the PV power goes to your DC to DC converter, which is your solar charger. This steps down that DC voltage to your safe battery charging voltage. And then from there, you have your inverter that will pull that power from your batteries and serve the household loads. For battery-based systems, you're going to need batteries to store that extra energy, and also that solar charger that I spoke of. In summary, photovoltaic modules harvest energy from the sun and converts it to DC power. So you will need at least another converter to convert the DC power to AC power that your home uses, and that's what we see here is the inverter. Now that you know functionally how a solar system works, you now need to consider what your solar goals are. We'll cover this more in a later video, but start thinking about it now. Is your goal for backup, or is it to make your bills cheaper? Or are you thinking about being more independent and going off grid? You need to consider these before making your decision. That wraps up a functional overview of a PV system. Thanks for joining me.